Now, today we are talking about the electrical design tools, right? The Dassault Systems electrical suite. And I wanted to just put it out there because some folks really only know that there's the 3D tool that we all know and love, and then the electrical tool. But there's a lot of other tools that we also have, collaboration and simulation, data management, all these different tools that are all starting to really work together cohesively. And not to mention just the SolidWorks stuff, right? There's also the whole Dassault Systems, the 3D Experience platform, which is a whole nother level of tools on top of that as well that you could take advantage of. So if you're interested in learning any more about that all these different tools, please reach out, let us know. We'll be glad to go over and talk a little bit deeper about all these different tools. Now, the typical design workflow that I see when working in the schematic package, no matter what schematic package that we have, is people are dropping in blocks, dropping in their symbols, and they're adding lines to that. And a lot of times they're just adding a text box to identify what those blocks and lines are for. And then they're taking that information and they're taking it separately, not and manually typing in a bill of materials, to from report, whatever it is, in something like Excel or even Google Sheets. And then there's the third part, which in my opinion, is probably the most important part, is second checking and auditing that process and making sure that what you designed and what you put in your report is correct. Well, what SolidWorks Electrical and Electrical Schematic Designer allow you to do, it takes that reporting aspect and that design rule check and brings it up front in while you're doing your design, right? This is the major differentiator between this tool, these tools, and other CAD electrical schematic design tools, right? It allows you to generate and maintain those accurate reports while you're doing those designs. Now, the main hub of information inside of Electrical Schematic Designer / SolidWorks Electrical is really the manufacturer part library. Okay, each manufacturer part can have a lot of metadata associated to it. And besides the individual metadata about the parts, you can actually assign different symbols, right? We have a line diagram, detailed schematic symbol, 3D model, 2D footprint, and more like a connection label, right? There's more information that you can include and start to really make your library robust. And as not only robust, but make it so that it's it's automated as far as, oh, you know the part you want to use. I'm just going to drop in the symbol that already is associated to that part as well. Now, the other major piece of the puzzle is the bidirectional communication between the electrical and the 3D side. We're not going to get into 3D today. We're really going to focus on the data behind the PLC. But something that a lot of folks are curious about and want to know more about is this directional communication. So in the middle of the screen, you can see that I have on the left-hand side is SolidWorks Electrical, and on the right-hand side is SolidWorks, the core 3D modeling tool that we all know and love, right? And inside of that, in the closer to the inside, we have the component tree from electrical, which is also available in mechanical. Well, if I'm the electrical engineer, I can go ahead and drop in P2, right? I've got a component, I have manufacturer part information associated to it. Now over on the right-hand side, my teammate, my counterpart, who's doing the mechanical design can simply right-click, insert, and drop that pump in, made it as needed. Now, as we all know, a lot of times that the mechanical engineer is the one who might be speccing out pumps and motors and valves and stuff like that, right? Furnaces, whatever it may be. They can go in and add a new component from the 3D side. And now over on the electrical side where I live most of my life, now I can come in here and simply say, right click on P2 and insert symbol, right? Because it comes back to those manufacturer, those representations of that manufacturer part that we see here. All right, get all that out of the way. Let's talk a little bit about what we're actually going to be doing today and working with programmable logic controllers, PLCs for short, right? This is just a basic PLC. No description in that regards right now, but what is a programmable logic controller? What can you do with this? What is it for, right? A lot of automation companies, a lot of automation, the automation industry, industrial enclosures, right? That kind of world, they live and breathe by these types of devices, right? Well, this is just really just a glorified computer for the most part, right? You're giving it logic. It's in the title of the name there. You're giving it certain things that it can do, which is turn things on, turn things off, things like that, right? But you need some sort of input, right? That's where these types of devices come into play. Your buttons, your switches, your emergency stops, things like that. And those those devices, that logic now that's controlled by this PLC will then go and turn on lights and pumps and motors and whatever else you have, right? So all of these things make up our system, right? Our overall system that we want to be able to document inside of SOLIDWORKS Electrical or Electrical Schematic Designer. Now, if you're unfamiliar with this, I just threw this in here as kind of a get us all to the same page, right? PLCs. There's a few different types of PLCs that you can work with, and so a few different items we have the fixed type, we have modular, we have distributed, and it really depends on your end application on what and the complexity of your application of which one you're going to choose, right? There's a lot of different brands, there's a lot of different companies that you can set a standard. I know a lot of companies out there that they only work with brand XYZ, right? And so mainly because they know the programming language behind those. But any one of those can all be used inside of SOLIDWORKS Electrical or Electrical Schematic Designer. Case in point here, I just said it, right? Any one of those different types of models, that information behind that can be captured in your overall top level assembly. Realistically, right, this is where, to kind of give it the grand picture of where things will fall, that PLC can help to control something like what we see on the screen right now. So what are we expecting to see here today? What we're going to do is we are going to build a brand new PLC using our PLC manager. That we're also going to go ahead and we're going to edit the PLC, and we're going to work with our IOs, all the different pins and terminals that are associated to all those different modules we're working with. And of course, we're going to draw all that information out. There is an automated way. I'll show you. It's pretty easy. And then we're going to go ahead and just talk through, right, that meat and potatoes, why we're building all this, why we're doing that is to generate these reports. This is the value that we get out of this, to be able to wire this thing up in reality later on. Now, before I get into the live presentation, I did mention a few times, you might have heard me and you might have been confused by it. What path do you really want to go down, right? There's desktop and there's cloud. Now, if you notice on the screen, I have an image on the left is the desktop version, and on the right is the cloud version. There's not a heck of a lot of difference. They're very similar. There are certain nuances about each tool to make it more of a desktop tool, and there's certain nuances on the right-hand side that will make it part of the cloud tool as far as how it would connect to 3D Experience platform. And just so you can kind of see the really slight differences that we see here, but overall, how the software behaves in both sides and everything I'm going to show today is the same in both tools. Okay. And altogether, just like I showed on that what to expect slide, we can do all this same stuff in both tools as well. So without further ado, let's jump in and go live. So let me go and find my tool. All right. So I have SOLIDWORKS Electrical open right now. Again, I could have done this in Electrical Schematic Designer as well. And I already have my project open. Now, this is how I organize this project. If you're new to SOLIDWORKS Electrical, a lot of the project information here can be totally customizable. This is just how I decided I wanted to build this particular project. Okay. And some of the nice things that I added to this, which I thought was kind of cool and can kind of automate, is each of these folders. What I was able to do was customize, and if I add a new sheet, well, it starts to build in and automates the numbering scheme. So if you have a specific numbering scheme that you want for your sheets, you can start to build stuff like that into the into the project structure. So you don't have to think about and try to rename every time you have a new sheet and give it a new fancy name. All right. But again, today we're working with our logic controller, and we're going to be working with some PLC. So let's jump in to our PLC manager. So under the electrical project, we have a tab for our icon for PLCs. Now I do have a few, just to kind of help save us some time. I do have a couple PLCs that I have pre-built, just so we have a starting point. And I have PLC 01 here and my remote IO as well. Now, as far how you decide you want to organize your PLC. So in this case here, I have my PLC 1, I have a power supply, and I have a rack, and I have all the modules inside of that rack. And the remote IO, it's set up slightly different. So if you're comfortable and you use PLCs all the time, you would probably know that in this case here, I'll pull it up, the power supply in this 1756 series is actually outside of the rack, right? So again, this is just how I designed it. You don't have to use this manager the same way, but this is just a in my opinion, the best practice of how to organize it inside of the electrical tool. So what I've done is I've created my PLC. My power supply lives outside of the rack, and then I have my modules inside of there as well. Okay. So let's go ahead and build a new one. We're going to build PLC 02. And automatically it knows, I've told the software, I've customized it a little bit to tell it that I want it to be PLC 02. If you're coming from Europe or certain areas of the country or the world that require you to have a specific naming convention, I know in certain areas of Europe, it's N for a lot of PLC components, that's the root that you have to use, so that you can set that if you'd like to. What I'm going to do here is also set a configuration, and I'm going to call this logic controller number 2. All right. All right, cool. So we have that. We have the base for our PLC. Let's go ahead and add a power supply. So right out of the gate, it's going to give me certain types of modules. These aren't the ones I want. A lot of times, personally, I recommend just removing filters. If you know you're working with a certain series, you're going to know the part numbers a lot of times anyway. So I'm going to go ahead and type in the parts that I want. And the first one I want is this power supply right here. And now we'll go ahead and add a rack. Pretty straightforward, right? There's a lot of different things. If you notice as I'm going through this, I'm just using and I'm typing in the reference here. But if there's, maybe you don't know exactly which part you want to use, there's a lot of other options here for filtering out and trying to find the appropriate part, whether it's an 8-port or a 16-port or something like that, as far as an input or output too. You can set up the filters to work with that. But right now, to kind of make this a little easier on all of us, I'm just typing in some part numbers here. All right, I added my rack, and it automatically knows based on the rack that I've selected that there are 4 slots in there, right? In the top one here, you can see that it's a 7-slot rack. It knew to automatically add 7 slots. And I'll go ahead and start to add some modules here as well. 1756, 65, and I'll grab this one. Now, one thing you notice, I'm actually going to remove that real quick and show this again. 65. I did have 2 versions of this, right? I have one that has a dot, an AB dot in front of it. And so just to clarify, why would you need 2 of them in here? Well, you don't. You can have one, and I do recommend having one, but I purposely did this so you can see that I can have 2 of the same part. What I did here was I actually built this one from scratch myself. I have the spec sheet and I built it out. And then the second one here actually came from what we call our electrical content portal. So the electrical content portal, if you go to Google, you can type in SolidWorks electrical content portal. You'll have to log in, and you can come in here and you can find a lot of the parts. You can search based off of the brand, the part number, whatever it may be, and you can find the catalog has millions of parts in here. But these are the most downloaded ones here. So as you can see, as a lot of automation equipment, you have Schneider, Mitsubishi, Rockwell, Allen Bradley, Omron. Those are some of the biggest ones. Phoenix, right? A lot of these parts are, Phoenix has 54,000 manufactured parts in here. So hopefully you can find what you're looking for inside of here. All you need to do is click on this. You can do a quick search through the search bar at the top, download that as a zip file, a proprietary zip file for SolidWorks Electrical, and it will allow you to bring it in, and you can drop it into your library as needed. I'm going to go ahead and select this one though, and we'll continue on. I'll add a few more parts in here to try to speed this up. 56 and 2T. While I'm going through this, Charles, are there any questions while I'm trying to type some of these out? I'll take your silence as no, so that's okay.
Oh, sorry, I was muted there. We had one question come in about the IO link blocks, basically the modular blocks that are basically mounted or connected via DIN cables that work as breakouts for the IOs, possibly with that. And one of the things, those can be handled in several different ways. One of the ways you could do, you can keep them as a PLC if you wanted to. You could create them as a connector. You can have them just as a general component, and there's several different ways of displaying those on your, in your schematics, right? You can do those through the different ways.
Cool, thank you.
Yep.
All right, so one other thing I want to do here is make sure that we drop this when we generate this onto and build these on our sheets, that they fall onto the right page. So I am going to do that now before I forget. And I want to make sure that they're all going to fall into that 500 folder. In addition to that, I want to take these modules and I want to assign them to PLC 02. All right. So we are done with this PLC 02 here. We've added our power supply, the rack, and all the modules there. The default for a lot of these is N, like I said earlier. I did change those to make my own add my own route for the type of part it is. So if you're curious about that, please let us know. I'll be glad to show everybody later on how I did that. But right now, what we're going to do is we are actually going to go ahead and start to build some of those PLCs right in our project. Okay. So first I'm going to do is that PLC 01 that I already had on my page. And if you're curious about shortcut hotkeys, I always get people, hey, can you do keyboard shortcuts? Control E is your friend, zoom extents as far as that, or actually a double click of the middle mouse button and it will zoom extents as well. Pretty nice. All right. So from the schematic tab, because we are working in a schematic here, actually a mixed scheme, we have this tool called the Insert PLC or the Dynamic PLC Insertion. Okay, it's not a symbol. It is a symbol, but it's not a traditional symbol with that I have to sit here and try to draw out and add connection points to. What this tool allows me to do is it uses what's called a configuration in the software. There's a piece of the software that has all these different configurations. We're going to talk about this a little bit more in detail in a few minutes, but what that's doing is it's using a unique configuration for my PLCs. I've customized it for me, for my use, for my company, or you can build one for your company as well. So under the schematic tab, I'm going to go to Insert PLC, and I'm going to select an existing PLC. So first and foremost, I'm going to start with PLC 01. And I want to grab that power supply and drop that into place. Now, this is that configuration I was just talking about. It knows to use this one here. And I have 4 pins on there, right? You could see those 4 connection points. And one of the things I could potentially do is change the direction if I want. Right now, they are outputs. So I'm going to go and simply just drop them in like this, and we can see our power supply on our sheet. Let's do that again a couple more times. We can create a brand new one from scratch, or because we just went through this and I showed you the PLC manager, we're going to use an existing one. And this time we're going to go ahead and grab module 1. Now, before I drop in module 1, this one here has some inputs and outputs. Now you could very well just drop this in. If I left click right now, it'll drop it into place as we see here. Or an option that you have, and this works with connectors too, is I can maybe turn off certain pins. So in my case here, I'm going to turn off my outputs. I'll turn off the ground too. And you can see that the size of the symbol changed. Remember, this is a configurator. There's a dynamic tool that allows you to change the shape and not the shape, but changes the size, the overall size of the PLC because, well, I don't need it to be so long because I've turned off some of those connection points. So I'm going to go ahead and this is the inputs. So I'm going to turn it this way. So that way from left to right, all my inputs are coming in over here. And now it shows my outputs. It's automatically going to change and let me add those. And I'll just drop that in over here as well. Now notice that on this one here, it has angles on it. That's because it's not the end, right? 1 and 9 are the first and last. So it gives me a flat edge. That's something you can change. You don't have to have it do that. but just wanted to show that in here to show that you can show that there's a break, right? This isn't the entire component. There's more to this component somewhere else in my schematic. Let's go ahead and add the other two modules here. And I'll just drop those in just so you can see how easy it is to drop these in as we need to. Now, where does all this information come from? Again, this is all driven from that configuration. So back in that configuration that I showed before, I didn't really go into this yet, but we're working with this configuration. Well, we can change the size and shape of each one of these symbols. We can determine what kind of information we want to show up on the top and the bottom of each one of those symbols. When we generate a drawing, we'll get into this. I'll show this again in a little bit. We can actually tell it where exactly on the sheet we want it to put it. We want this to fall. And then the connection point information, and then even circuit information. We're going to get into a little bit more detail with this as well as we move a little closer. So there is a lot of data in here and a lot of things you can automate to really make your process and your workflow and fine tune that process to get your job done faster. Now, instead of having to go through and add them all, I already did. I added slot 4, 5, 6, and 7 in here. You can get a quick view of all the inputs, and I'll open up one of the outputs here. You can see this as well. All right. So that was a simple way of adding our PLC components through the schematic tab, insert PLC. But if you don't want to have to go through and add every single one like that, there is another option where I can go ahead and use this button up here called Generate Drawings. So what I'm going to do now is I'm going to go ahead and simply highlight all of the remote IO, and I am going to select Generate Drawings. Let me get a better view here. Notice on the left-hand side, you can still see our document tree. Okay, and I'm going to generate the drawings here. And what's going to happen is it's going to start to automatically create new drawings and populate each one of those drawings with a different component, right? So each sheet, and some companies like this, some companies like to fill up their sheets as much as possible. This is how this tool operates, where you can have each module on its own page. We'll close this, take a look at those. Let's open up 506. All right. So now we can see that remote IO, we have this module here, module 1, this IB8. But in addition to in addition to just the PLC, where the heck did these come from? How the heck did these get in here? Why do we have all this additional data in here? Well, we have inside of those remote IO here, we can see all the terminals down here, and we can see that we have additional information. In particular, we have an associated macro, okay? What that means, what is a macro? Let me explain that first. So a macro, I'm not a huge fan of calling it a macro. I like to actually call it a reusable circuit or a common schematic, a piece of a circuit or an entire circuit, if you want to, that you're going to reuse over and over again, right? You can see here that I have two normally closed, normally opens. I have some limit switches in here as well. And how does it know to pick those? Where does it say to use those? Well, I just showed it real quick, skimmed over it, but I told it to choose those, right? Normally closed contact. What this is that this little tiny piece of a circuit here, these two terminals and that closed contact is a circuit. And what I've done is I've turned each one of those into what we call a macro. So we have a symbols library, we have a manufacturer part library, and we also have a macros library. And inside that library, I've created all these little mini circuits to help me make my projects more robust. So I have all different kinds of sensors and switches and everything else in here. And I can make 1,000 more if I really wanted to. I was just trying to get the point across to everybody on the call of how big you can make these, how detailed you can make these if you wanted to. Now, based on that PLC that I showed before, the module 1, that contact here, I can pick which one I want and choose which one I want to put in there. Or If you don't put anything in that field, inside of that PLC configuration, there is an option here that based on an analog PLC connection point or an analog PLC output connection point, I can tell it every time I use this type of circuit, every time the manufacturer part has that or this or a miscellaneous or digital, I want you to use this type of macro there, this circuit, this symbol. And so there's a lot of different ways you can utilize this tool to get your output, get exactly what you want the first time, rather than have to sit here and draw this, add a terminal, add a contact, add another terminal, go in and manipulate all that data. Okay. So it's very powerful. The best part about these macros is that I can take this whole section here or any one of these. I'll just do one little piece of it, I guess, just like I did with the other ones there. Grab just this little section. And I'll go ahead and simply left click and drag and pull it over. I can give it a new name. I can add it to a library if I want. And just like that, it is now in my library. If I'm in a collaborative server and I'm working with multiple people, as soon as I create that, that is now available for everybody to use. Everybody that on my team can build this. So you can have one person on your team cranking out circuits, building all these mini circuits, like maybe a power supply with all of its input power coming in, right? Or different connectors, different variations of a certain connector, and turn them into macros and build a huge library that includes not just the graphic, but all of the metadata, right? The manufacturer part data behind this, because this one even has the J3 in here for that terminal. And I believe I added one in here as well. No, I did not, but I could have added a contact or a contactor to this as well. So, all right, moving right along. We have our PLCs. And we have this last one that I worked with here, we built before. So let's go ahead and now add a little bit more data to this particular PLC before we generate drawings for this. So we have our PLC here. And we have expand this a little bit more. We have all of our pins, all the terminals, everything about this. But there's certain information, especially when dealing with a PLC, that you need. Channel, a physical address, or just the address. You need, a lot of folks use mnemonic for PLC. So there's a lot of additional pieces of information that you would utilize when working with these PLCs. So what we're going to do here is, let me see if I can change it here first. Oh, I'll do it later. I'll do that after. Grab this. What I want to do is I'm going to assign a mnemonic for these to all of them in one shot. So there's an option here where I can just select all of these and add a new input output. And just like that, I now have these. Now you can see here why I explained that whole configuration thing and all that circuit information. I hope I didn't confuse anybody. But now I can come in here and I can choose individually, or if I leave it as the default, it's going to look at the circuit type of that is set up in that configuration and choose the appropriate macro instead of me choosing one for every single one. Not everybody's going to want to go through this entire list and go, oh, I got to choose this macro and choose this macro and choose this macro, right? That could be painful, but to each his own on how you want to do it. You can use this, or you can use the configuration. So what I'm going to do now is let's go ahead and just edit one of these. I'm going to add a description. Let's call it, well, we're going to use a normally open push button input for this. And I'm going to find a push button macro. Where is it? And if I can't find one, I'll just use a different one for now. Yeah, I'll just use this for now. I know it's not a push button, but you can see that we're going to change this in a minute anyway. So we see it. We have our normally open push button, and we have this. Well, instead of having to go through and change the description for every single one of these, what we can do is we have the ability to edit our inputs and outputs. We can do it here in this data grid where it's a little bit easier, not a data grid, and this other page where it's a little easier to go through, or we can actually go into more of a data grid style, like a spreadsheet. And now from here, a lot of times people will take information right from their programming software, right? There's a lot of proprietary programming software for each one of the building your ladder logic out for all those PLCs. And you might take certain information out of that and put it into a spreadsheet and utilize it here. So now in this data grid, I could take a spreadsheet like I have here and copy certain fields, or all of them if I really wanted to. And now I can just simply drop these into place. I can even add more data if I want. And you can notice here that it's not a push button anymore for this one. It's a prox. So I'm going to come in here and try to find a prox for this. And there we go. I've changed that on the fly here. And now the next thing we will do in here is also tell the software we want to put all of these under the packaging function. We'll get into, if you have a question about locations and functions, it's a very common piece of the software, very valuable use in the software is locations and functions, really helping you define your bill of materials and reports later on as well. Helping you organize your data a lot more, I could say. So I'm going to go ahead and move all of these into the packaging line. And just like that, they're now all together. All of PLC 1, the remote IO, and everything in PLC 2 is in here. Now, if you notice, I have a green square on some of them and a blue square on others. The green square means that it's already been added to the schematic or a schematic somewhere in my project, and these just are not in there yet. All right. So now what we can do, go back to that. Now what we can do is we can actually go ahead and we are going to generate the drawings for PLC 02. And we should start to see here in a second on the document tree that's kind of hiding behind our PLC manager. We'll see a couple more sheets pop up. Perfect opportunity to get a sip of water. Maybe go get a cup of coffee. And we will close. Now we can see some.
I was going to interject really quick. It's one of those things that the software is doing it for you, right? So you can take your little bit of break and still have work done.
Yeah. Good call. So let's go ahead and open up this sheet here. And we can see that we have our rack 1 mod 1, and we have that prox that I added and we changed, right? We can see that we have that proximity switch sensor in there. And we have all that data associated to this. Now, what else should we be doing in addition to this? Obviously, there's a heck of a lot more to the schematic that we probably want to add after this with PLCs. There's probably a lot more data, right? We're here to focus on the PLC. So what else can we do with the PLCs here? Well, one thing that we can probably do is, well, let's just make sure some of our data is correct. In particular, we haven't numbered anything yet. We haven't put a wire number on any of our information. You can see here that I have a design rule check called wires without mark. And that's listing everything in my project because I haven't run through that functionality yet, that process. In addition to that one, there are a lot of different types of design rule checks that you can utilize. Just to name a few, there's voltage drop, fill duct ratios. One that I find that works that a lot of people will use. Where is it? Well, wires not routed in 3D. There's one for the overall size of a wire, right? Maximum section versus what's available for the component. So in some cases, you can actually define, and I'll show it really quick, inside of a manufacturer part. Again, there's a lot of information. It can go really deep down the rabbit hole here. But in this case here, this terminal, the max that it can handle is a 12 gauge to a 30 gauge. Well, if you put a 10 gauge wire on here in the schematic and you're routing a 10 gauge wire, you can run that report and it'll tell you, hey, by the way, you're trying to route a 10 gauge wire, but you told me in the software that this part can only handle 12 gauge. So it's a nice little sanity check to make sure that things are being wired correctly based on the specs of that part. So here again, back to our wires without mark, you can see that we have a lot of them in here that don't have numbers. So let's go ahead and number our wires. So under the process tab, there is a function called number new wires. Super hard to do. We're going to simply select once, select yes, and let the software number everything for us. Now, let me redo that because it looks like it didn't want to number all of them for me. There we go. You'll see why it didn't do that in a second here. So now you can see here that I have wire 106, 107, 108, 109. That's just how I have this project set up. If you wanted to go left to right, then top to bottom, so be it. You can set that up right now. I believe the project, if I look at my configs, it's set up to go top to bottom, then left to right. So to each his own on how you want to do that. Now, something that a lot of companies also want to see when they do this, and real quick before I do that, I'll just show you that now if I come back to wires without mark, guess what? All that information is gone because it's only going to highlight the ones that don't have a mark yet. Another little sanity check in there. Okay, so moving right along, we have our wire numbering here. But a lot of folks, I run into this all the time. Charles, you probably run into this too. People want a different number for their wire numbering scheme. Well, there's a formula behind how this information is captured. But a lot of times they want to capture the information from the PLC, and that's the wire number, especially the one coming right out of the PLC. Okay, well, there is a tool called Propagate Data from Connected Objects. And what that allows us to do, it allows us to pull the information, that in this case, we're going to pull the channel address, and we're going to turn that channel address into the number, the wire number here. Okay, so first we need to do is add a new propagation. Telling the software we want to add something new. We're going to use it from the PLC channel, and we're going to pick the channel address, and we're going to use equipotential, and we're going to use mark. And then there's this little button here for update wire marks. If I don't do that, then it's not going to change anything that's already been numbered. But we're going to go ahead and update. And now we can see that that first segment, at least of this line here, has now been changed. If you want that to continue down, well, guess what? You've got to come in here, add propagation, and you can keep pushing that number back and forward, all the way down the line if you need to, for all of the wires in your project. So to each his own. Again, I'm just showing you some of the capabilities that are built in here to help automate this process. So you're not, a lot of folks still today are coming in here, finding their wire and numbering the wire individually, manually, right? And that could be very painful, right? And we're trying to help you make sure that you're getting your job done faster. So, all right, so moving right along with that, what did I want to show next here? There's so much I could possibly show. How much time we got? We got a few more minutes. So one thing that I like to bring up too, I have some, you could see that I have terminal block 1, LS1, all my roots, my marks for every one of my components, they're in blue. I did that myself. Some folks want it to stay in black. Some people want to see it in red, green, purple, whatever color you want. Well, you can control that from within the symbol if you want. Right, you can see that I have it in blue here, and you can change every single symbol if you decide to. But let's say I build one and I want it to be blue, but Charles doesn't like blue. Maybe he's colorblind and he wants to see his in black or red, right, or something else. Well, instead of having to go through every symbol and size, maybe I like to see a certain font size. There is an option in the tool where we can come into attributes, and I can choose here, and I'm simply just going to globally for this entire project change the color to red for the parent tag and also for the regular tag, and now we'll see everything shift automatically. That's something that a lot of people ask me about. I'm here, I had a few minutes, might as well throw that in there and let everybody see how that works. Okay, moving right along. Reports. What do we have for our reports? Well, right? We created all this data so we can get the bill of materials. We can get a wire report out of this as well about our PLCs. We can see a lot of different parts that we might have here, and we can see here different version of it, right? There's different ways to organize this. You can have the same bill of materials, right? The same configuration, but you can organize it in different manners. You can duplicate that report and set it up so that maybe one version of the bill of materials is for you, right? It has all the data. And there's another version that is for the logistics teams who's going to order this stuff for you. So you need to have the vendor information, and you need to have the vendor part number as well. And then maybe a third version just for the guys on the shop floor, the gals on the shop floor who are helping to assemble this, or maybe your subcontractor who's helping you assemble it as well. And they don't need to know all that data. They just need to see certain parts, right? I need to know what it is and where it goes and how to put it in. So to each his own on how you want to build that. You have your wire reports. Let's just go ahead and generate this. And you have the ability to add it directly to the project, or maybe you want to take this information and push it back out to Excel, a text file, or XML. You can do that as well. So we'll go ahead and generate our drawings. And I'm just going to go ahead and say okay here. And again, just like Charles said, it's automating this process. It's doing it for you. So you don't have to sit here in front of Excel and try to type all this data out and make sure that you've got all the right parts and the right pins and the right back shells and the right, well, in our case, PLC modules that you need to order. Take a look down here. We have our bill of materials. A quick view of all the different parts we have in our project. Different view of it, slightly the same, but I purposely did this so you can see that, well, some people want to put all their bill materials on a portrait view versus landscape, right? I'm just trying to give people options out there. Maybe it's hitting home for some of you as far as what you do in your shop and back in your office. And then we have our bill of material, not our bill of materials, our to from report here. You can see that we have our origin destination arrows, not origin destination, our origin and destination. We have our wire numbers. We have the gauge, and we don't have length in there right now. Okay, we could. I'm not going to take the time to go and add that, but we could add a length. If we had routed this project, if we took the time to build this in 3D as well and automatically routed all this in 3D, that length information could get pushed back into this project. We don't have the 3D side set up for this. We could manually come in and add a length for each one of these segments. Again, to each his own. You don't have to. It's something that's there and is available for you if you decide you want to go down that route. And the last thing we can do is we can actually export this project to a PDF. And I'll go ahead and drop it on my, just going to call it that same one. And export. And right now it's just taking everything from this project and turning it into a PDF. The nice thing with the PDF is that it is an intelligent PDF. I don't have any in there. I should have added a few on another page somewhere, but origin destination arrows are hyperlinked. If you have multiple references for the same component, right? If I had a reference for module 1 on 3 or 4 different pages, then each of those are all linked together. So you can see here all of my parts. I do have a component tree, and I can click on certain ones, and it will help me find all those parts no matter where they are throughout the project. So instead of having to print out that really big book of all the different parts in my project, you know, I can come into the PDF. I can just have a ruggedized iPad if I'm out in the field, have that iPad in one hand or whatever kind of tablet you want in one hand, and I can have my fluke in the other hand, and I'm ringing out cables, right? It's much easier than that old 10-pound 11 by 17 book that you got to carry around and somewhere like I used to have to do all the time. All right. Let's jump back over to here. So the overall benefits of utilizing this tool, right? One of the biggest things, and I can't stress it enough, is being able to communicate and collaborate. You saw really quickly that I was able to create that macro, for example. As soon as I add it to the library, it's there for everybody to use. So if I was in a network environment, we would all be able to share that and you collaborate much faster, much easier, instead of having to share files back and forth. Hey, did you get that file I sent you? Oh, do you have this? It all lives on that collaborative server, which of course, increasing that communication and collaboration allows you to improve your time to market, increases the consistent manufacturing and assembly, reduces defects and scrap, and streamlines the overall development of everything. One question that I always ask everybody when I go to meetings and stuff, who are you trying to communicate with? Right? Because right now we just did what the electrical engineer or the systems engineer is going to do. He's going to build a PLC, he's going to work with it, maybe print out a PDF. But who's that for? What's it for? Why are you doing all of this? You know, it's not just about electrical and mechanical. What about analysts? What about the assembly team, the shop floor? What about management? Like keep everybody informed about what's going on. And what about the other teams that really aren't in the engineering side, but marketing and logistics? And you know, they can all be a part of this. I said you can have multiple versions of a bill of materials. That's valuable to be able to just automatically build that one time and then automatically push that out to them as needed. You know, things that also think about going with this tool, you have the options of going with the standard with SOLIDWORKS PDM, or you know, you have the ability to create a schematic right from PDM, or I'm not sorry, not a whole schematic, but the project right from in PDM and manage all that data inside of PDM, contains and where used and the stuff that you're used to using with inside of PDM, and have your bill of materials visible inside of PDM. Or you also have the option of going with the cloud data management, where you have 3D space and bookmark editor and being able to work with collaborative lifecycle management, where you can set up workflows and control there. And then one that I'm really starting to embrace is the relations, where you can visualize and see where things are actually being used as you're building out your projects. Speaking of collaboration, other things that you can do with this is what about marketing, right? I mentioned that a second ago, but what can you do with these assemblies and these projects that you build, and you take the time, you do all this work to make this thing look real? Well, then you could take it and use SOLIDWORKS Visualize and render it and make it look even more real, more realistic, right? Here's just a few examples that I did. Here's a quick video of this machine that I had put together. Frozen drink machine. You can see some of the just looks pretty cool to me. Be able to use that for some marketing. And then of course there's analysts being able to take some things and do some thermal analysis on certain types of devices and components that you work with, right? These are all valuable. You're sharing this data, you're collaborating to make your projects, your products better. So with that said, I'm going to stop here. I'm going to take some time for some questions. Charles has probably been typing away like a madman on the back end here, answering questions. I'm going to leave this up. If you're interested in a little bit more data about electrical schematic designer, SOLIDWORKS electrical, take a picture with your phone of the QR codes that we have there. There's also a video about what electrical schematic designer, we call it ESX. And so you can see that first look video of how we figured it would work. What would the day in the life of an engineer using electrical schematic designer be? I hope everybody has a great day. Have a great rest of the week. And I hope you learned something about PLCs and how to manage and organize your PLCs within SOLIDWORKS electrical/electrical schematic designer. Have a great day.